In this video, I am going to discuss about time series analysis. Time series analysis involves studying the pattern of values of a variable over time to identify any underlying trends, seasonality, cycles, and irregular fluctuations. These irregular fluctuations are also called the random factors or also known as the noise. Time series analysis is used to help understand the past behavior of the data and to make forecasts about the future behavior of the data. When it comes to forecasting using time series analysis, always remember we are using the past data, and based on the past data, we are forecasting for the future. In time series analysis, the time series data is usually plotted on a graph with time on the x-axis and the variable of interest on the y-axis. And this is why this method is called the time series analysis. This is the series of data with relative to the time. Now let's discuss about the components of time series analysis. These are very important topics. The trend. The trend is the long-term pattern in the data, such as an increasing or decreasing trend over time. Remember, there can be either increasing or decreasing trend. Seasonality. Seasonality refers to the regular repeating patterns in the data that occur over a fixed period of time, such as daily, weekly, or monthly cycles. When it comes to business and financial, each quarter of the year can be considered as a season. So there are 4 quarters, which means there are 4 seasons. Cyclical. The cyclical component of a time series refers to the long-term cycles or fluctuations that occur over a period of years or decades. These cycles are often related to economic or business cycles and can be difficult to model and forecast. We discussed about economic and business cycles in a previous lesson, if you can remember. These are the trade cycles. These can be occur over a period of years or decades. If you can remember, there are 4 sections in a trade cycle: expansion, recession, depression, and recovery. Random or noise. The random component of a time series represents the unpredictable, irregular fluctuations in the data and are not explained by the other components. When it comes to time series analysis, it is difficult to predict the cyclical and random factors, but trend and the seasonalities can be calculated reliably. So we give more focus to the trend and seasonality calculations in this lesson. Time series analysis can be done by using 2 models. The first model is the additive model and the second model is the multiplicative model. Let's talk about the additive model first. The time series analysis additive model is a statistical model used to decompose a time series into its underlying components: trend, seasonal variation, cyclical variation, and random variation. This method assumes that the components are constant amounts. This means absolute values. The model assumes that the time series can be expressed as the sum of these 4 components. As the title says, this is the additive model. So we are adding each component of the time series analysis. So we are adding the trend, seasonal variation, cyclical variation, and random variation in order to calculate the forecast. Now let's discuss about the multiplicative model. The multiplicative model is another statistical model used for time series analysis, similar to time series additive model. However, instead of assuming that the time series can be expressed as the sum of its components, the multiplicative model assumes that the components are multiplied together. This method assumes that the components are relative values. This is how we can use the multiplicative model. Instead of adding the time series analysis components, now we are multiplying to get the final forecast value. Trend multiplied by the seasonal variation multiplied by the cycle multiplied by the random variation. so we can get the forecast value. These are the steps we have to follow in order to do a time series analysis. First, we have to find the trend line or the best fit line. This will be in form of an equation. Then we have to find the seasonal variations. Then we have to adjust the trend line for seasonal variations. Then we can finally forecast for the future. There is another important thing to know before we continue. We need to know about the extrapolation and interpolation. Extrapolation is we are considering the values out of our range, which means out of the past data. This is unreliable when it comes to forecasting. Interpolation is where we are forecasting the values within the given range. This is a reliable way to forecast. So always remember when it comes to forecasting, extrapolation will be unreliable. Now let's talk about the first step, which is to find the trend. We can find the trend for time series analysis by each of these methods. The first method is inspection. The second method is linear regression. The third is moving averages method. Let's discuss about the trend line by inspection. A trend line is a straight line that is used to represent the overall pattern or trend of a data series. In some cases, it may be possible to estimate the trend line by inspection or by visual inspection of the data. These are the steps we can follow in order to find the trend line by inspection. Plot the data on a graph with the time on the x-axis and the dependent variable on the y-axis. Look for any overall pattern or trend in the data. This could be an increasing or decreasing trend, or a pattern that shows a gradual change in the data over time. Draw a straight line that represents the overall trend of the data. The trend line should pass through the middle of the data points and follow the direction of the trend. Use the trend line to estimate the value of the dependent variable for a given value of the independent variable. Here is an example. These are the number of sales units sold during a year up until August. So the x-axis depicts the time in the form of month and the y-axis depicts the sales units. So the sales units is the dependent variable and the time is the independent variable. Look at the plotted data on the graph. Now let's do an inspection. As you can see, the points are gradually increasing, but we can identify a pattern because it is moving upward. Now we can visually see a line which represents the trend. Let's start from here. Now we can consider this line as the trend. This is the inspection method. We just visually observe the data on the graph and visually draw a line for the given data. So for this example, this trend is increasing. If the given data are gradually decreasing, we can also find a decreasing trend. This method is quick and easy, but not reliable when it comes to the calculations. That is the limitation of this method. So now we have to use either linear regression method or the moving average method. Simple linear regression method. This is also called the line of best fit. Simple linear regression is a statistical method used to model the relationship between dependent variable and an independent variable. It assumes that there is a linear relationship between the independent variable and the dependent variable, which can be expressed using a straight line. When it comes to linear regression, the linear regression based on some assumptions. A linear relationship between the independent variable and the dependent variable. Based on this assumption, we are calculating the trend line. for the given data sets. The goal of linear regression is to find the best fit line. Once the line of best fit is found, it can be used to make predictions about the dependent variable based on the values of the independent variable. This technique can be used to forecast both cost and revenue. Here are the assumptions for simple linear regression. Linearity. The relationship between the independent variable and the dependent variable should be linear. This means that the relationship between the two variables can be approximated by a straight line. Independence. The observations should be independent of each other. This means that the value of the dependent variable for one observation should not be related to the value of the independent variable for any other observation. Homoscedasticity. The variance of the errors should be constant across all values of the independent variable. This means that the variability of the dependent variable should be the same at all levels of the independent variable. Normality. The errors should be normally distributed. This means that the distribution of the errors should be a normal distribution. Outliers. There should be no significant outliers. Outliers are data points that lie far away from the other observations and can have a significant impact on the results of the analysis. This is the least square method. This comes under simple linear regression. This is the equation of the trend line. We can use the independent and dependent variables to find the trend line for each data sets. Capital T is the trend line. This is the dependent variable. Simple T is the time period. This is the independent variable. Simple B is the increase or decrease in one time period. This is also called the gradient or the slope of the trend line. Simple A is the point at which the trend line intersects the vertical axis. Using this formula, we can find the value for B. Simple N is the number of pairs of data. X is the quarter number. Y is the actual value. Using this formula, we can find the value for simple A. Y bar is the average of Y values. X bar is the average of X values. These formulas will be given in your exam, so you don't need to remember these. But you have to have the understanding how to use these formulas to find the trend line and other variables on the trend line. Now let's do this example. These are the past data for sales revenue starting from 2010 quarter 1 to 2011 quarter 4. First, we have to identify what is the independent variable and what is the dependent variable. Time is the independent variable. Depending on the time, we are measuring the sales revenue. So, sales revenue will be the dependent variable. Then what we have to do, we have to calculate the trend line. This is the formula. T equals to A plus B simple t. This simple t will be the x value. A equals to y bar minus bx bar. And we also have to find the b value. B equals to sigma x y minus sigma x sigma y 10 times n sigma x squared minus sigma x squared. Now we can start the calculation. First, we have to take the simple t values. Don't get confused with the quarter value here, Q1. You have to start from the beginning. This will be the time period of 1, 2, 3, 4, 5, 6, 7, 8. These are the simple t values, not the quarter value. Sigma x value is the total of these values, which is 36. 276.6. Now we can calculate the A and B values. A value equals to y bar minus bx bar. Y bar is the average of y values. Sigma y divided by the number of y values, 8, which equals to 276.6 divided by 8. So the x bar equals to sigma x divided by 8. 8 is the number of x values. See here 1, 2, 3, 4, 5, 6, 7, 8. This is the average. So this will be 36 divided by 8. This equals to 4.5. Now we have to find the b value. So b equals to 0.3476. Now we can calculate the a value. A equals a equals to 33.01. We can take this as 33. Now we have the trend line equation, which is t equals a plus b simple t. T equals a is 33 plus, let's take b as 0.348 t. This is the equation for trend line. Now that we found the trend line for the data sets, let's discuss about the variations around the trend line. This is the formula to find the variations around the trend line. Actual value divided by the trend for the respective time period. The trend line is a straight line which is equivalent to the average for the actual values. Now what we are going to do is we are going to adjust the trend line for the actual values because there are seasonal variations. These are the steps we have to follow. First, we have to calculate the trend value for the past data. Divide the actual value from the respective trend value. Calculate the average variance for comparable seasons. Finally, we can forecast for the future periods using the trend equation and the average variance. Let's continue this example. So now that we have found the equation for trend, we can assign the values for each time period and find the trend value for the each respective time period. T equals 33 plus 0.348 simple t. Let's find the trend value for 2010 quarter 1, which is the time period of 1. 2010 quarter 1. So here the simple t equals to 1. What we are going to do is assign this simple t value to this formula and find the trend value. Let's assign t equals 33 plus 0.348 multiplied by 1 because the time period is 1. So the trend value equals to 33.348. Likewise, now we have to assign the simple t value for the each time period and find the trend value for the each time period. So now we have all the trend values for each time period. Now we can calculate the variances for each time period. The formula to find the variance is variance equals to actual value divided by trend value. So let's find the variance for 2010 quarter 1. Actual value is 25.8. This divided by the trend value. The trend value is 33.348. This equals to 0.7736. Let's take it as 4. Likewise, now we have to calculate the variances for each time period. Now we have all the variances for each time period. So the next step is to calculate the average variance for comparable seasons. What is a comparable season? Comparable season is Q1 of each year and Q2 of each year, Q3 of each year and Q4 of each year. Here what we are going to do is take all the Q1 variances and take the average. So we have two Q1s, 2010 Q1 and 2011 Q1. So 0.774 plus 0.803 divided by 2. We divide this by 2 because we have only two values. If we have 3 Q1 values, we have to divide it by 3 because we are taking the average. This is the Q1 of 2010 plus Q1 of 2011. Then we divide by 2. So this is the average variance for comparable seasons of Q1. Likewise, now we have to calculate the average variances for Q2, Q3 and Q4. After that, we can start the forecasting for future periods. So let's forecast for 2012 quarter 1. Here how we are going to forecast for this time period. We calculated the trend line equation, which is this: T equals 33 plus 0.348 simple T. So simple T here will be 9 because 2012 quarter 1 will be the ninth time period. So what we are going to do here, find the T value. So the T value for 2012 quarter 1 is 36.132. So this is the trend value. Now we can multiply this trend value by the average variance for quarter 1. Multiply by average variance for quarter 1 is here. We calculated this, which is this 0.7885. So the forecast value is for 2012 quarter 1 will be 28.49, which means we can expect 28.49 sales revenue in 2012 quarter 1. Like that, now we can forecast for the future period because we have the trend line equation. Using that, we can find the trend value and we also have the average seasonal variation. Remember to multiply this seasonal variation by the trend value. So this is the simple linear regression calculation when it comes to time series analysis. Using this technique, we found the trend and also we found the variations. Using that trend and the seasonal variation, now we can forecast for the future. Let's say we have to forecast for 2012 quarter 2. What we have to do, assign the simple t value for the trend equation and take the average variance for quarter 2. Then multiply those values. Thank you for watching. See you in the next video.